Today we are going to start a new unit that's called Analytic Geometry. The idea is kind of the connection between algebra and geometry. So we're going to be using geometry ideas like segments and circles, but we're going to be connecting them to algebra by thinking about points and lines and graphs. So today we're going to be focusing on two ideas that are really closely connected, and that is distance and circles. So the distance formula is pretty messy actually when we look at it at first, but I'm going to show you where it comes from and that'll help it make more sense, I think. So it's d for distance is equal to the square root of x2 minus x1, and we're going to square that, plus y2 minus y1, and we're going to square that. That is a big, messy formula. So the idea of this is that we're going to be given 2 points, and remember points from algebra are x comma y, nice and alphabetical, just like x, y is alphabetical, x comma y in algebra, alphabetical. We're going to be given 2 points, and we want to find the distance between those 2 points. How far apart are those 2 points? Or if we connected them with a line segment, how long would that line segment be? And this formula is one way we can do that. We're also going to approach this idea graphically, and I'll show you how that works. Our other idea that we're going to be working with today is circles. And the algebra equation for a circle is x minus a squared plus y minus b squared equals r squared. All right, also a pretty big equation. Hopefully you see the connection between these. What do they have in common? Well, they both have 2 groups that are squared. Both groups are a subtraction, an x group, a y group. We've got a subtraction in there. We've got the squares. Those groups are added together. Well, what's different about them? The distance formula has that big square root in it, and the circle formula says it equals r squared. Well, we don't write it this way, but we could, if we wanted to, just take a square root of both sides of this, and then that would change it to just an r instead of an r squared, and then we'd have the big square root, and they would actually be exactly the same formula. So our distance formula and our circle equation are actually the same equation, but we don't write the circle equation with that square root. We leave it as equal to r squared. Now, we finished a unit recently about circles, and then we learned about circles in terms of area and circumference. So remember that the 2 important parts of a circle are its center. The center of this circle is going to be at A comma B, right? Those numbers in the parentheses, but notice that it's x minus A and our center is at just A. So it's going to be the opposite of the number in that parentheses group. And then the other important thing about a circle is its radius, and the radius is going to be r. Notice that the equation is r squared, so we're going to end up needing to take a square root to find what the radius of this circle is. Okay, so let's look at some examples of both distance and circles. So I'm going to bring up a graph to talk about distance here. And so in distance, let's say there's kind of 3 different ways that this problem could be given to you. One way it could be given to you is that it's just going to give you 2 points. So it might say -1, 4, and 7, -5, for example. And we want to find the distance between those 2 points. This is one way that the problem might be given to you. Okay, 2 different ways that we can solve this. The first way to solve this, and this is actually my preferred way, is by graphing. So what we're going to do, remember from algebra, this is our x, and this is our y. X is the horizontal one, y is the vertical one. And remember that each point is x comma y. I'm going to plot each of these points. So I'm going to plot this first point. X is -1, 1, 2, 3, 4, up on the y-axis. So there's that first point. And then I'm going to plot the second point. x's over to 7. 1, 2, 3, 4, 5, 6, 7. And 1, 2, 3, 4, 5 spots down on the y-axis. So there's that second point. Okay. This is actually the second way the problem could be given to you, is they could just give you the picture of the 2 points instead of giving you the numbers of the points. So 3 different kinds of problems on this assignment about distance. One way, they might just give you the number points. Okay? One way, they might give you the picture of the points, the graph. And then the third way the problem could be given is actually just by giving you a little line segment, and I'll say find the length of the line segment. Okay? So all 3 ways, the question is really the same. How far apart are those 2 points? How long is that line segment? How far apart are the endpoints? 2 ways to solve it. The first way is with the graph, and that's my preferred way. So what I'm going to do with this graph is I am going to turn this into a triangle by going straight over so that I'm right underneath that other point and then going straight up to connect so that I didn't just make any triangle, I made a right triangle. Now I can measure the horizontal and the vertical parts of this by counting boxes. So how many boxes across is the bottom of this one? 1, 2, 3, 4, 5, 6, 7, 8 boxes across that I can count on the bottom of this. And then how many boxes up? 1, 2, 3, 4, 5, 6, 7, 8, 9 boxes tall. And then how do we find the third side of a right triangle? The Pythagorean theorem. So I can do the Pythagorean theorem. A squared plus b squared equals c squared. So remember, c has to be the hypotenuse. So that's the part that we're looking for. So we're going to say 9 squared plus 8 squared, c squared. That's 81 plus 64. We add that together and we get 145, I think. I didn't grab my calculator. Yep, I think that's 145. And then to solve for c, we're going to take a square root. 145 is not a perfect square. It's so close. 144 is 12 squared, so it's super, super close, but it's not a perfect square, so we could just leave it right at 145 or pay attention to your directions on Khan Academy, and if it says that you can round it, then you could type it in a calculator and get a decimal and round that. Or we could just leave it right at that square root as well. Okay, so that's one way to solve it, and that's my preferred way. The other way to solve it is with that distance formula that I gave you. So that distance formula, I'll write up again, is that distance is equal to the square root of x1 minus x2 squared plus y1 minus y2 squared. Okay, so then what we would do is if we're given the numbers of the points, this formula is most convenient in that sense. So if we were given the numbers of the points, the -1, 4, and the 7, -5, then the formula is most convenient there. If you're given the graph, you would have to, from the graph, say, well, where are these points? Okay, well, that purple one, it's at 1, 2, 3, 4, 5, 6, 7 over and 5 down. And so we would have to find the coordinates then, find the numbers. So maybe not as convenient if you're given a picture. But what we would do is then say, I'm going to name that first one point number 1. So x1, y1 is that first point, that blue point. And then I would name the second point, point number 2. So that's my x2 and my y2, that purple point. Then I can go and plug in those numbers. So then x1 is -1 minus x2 is 7. And y1 is 4 minus y2 is -5. Caution, if you are going to choose to solve these problems using this formula, be very careful with negatives. So again, this is not my preferred way, and the negatives are a big part of that. I really prefer that Pythagorean theorem, but this is a valid way as well. And if you use any of the hints on Khan Academy, I'm going to go ahead and bet that they might use this formula. So I wanted to show this too. So -1 and -7, that makes -8 in parentheses. If you're going to type this into a calculator, those parentheses matter. Now when I do 4 minus a negative 5, minus a negative I'm really adding, so that makes 9 squared. So this would be 64 and 81, and I get 145, and we get the same answer that we got the other way, but we do have to be extra careful with those negatives if we do this. This, again, is most convenient if you're actually given the coordinates. Otherwise, if you're given the graph, you have to pull the coordinates off the graph. So, 2 options, both valid options. Personal preference, I like the Pythagorean theorem because it's something we already know. It's something we've practiced several different times in different ways. And so it's not like we're learning something brand new that way. All right, so that's the idea of distance. You might be given the 2 points as numbers. You might be given the 2 points already in a picture. You might be given that red line segment in the picture. No matter what, you can use Pythagorean theorem, or you can turn them into the xy points and you can use the formula. Okay, so that's our first idea for today, distance. The next idea is about circles. And for that, I'm going to look at Khan Academy. So with Khan Academy here, in this example, we're given our equation of a circle here. And so we've got this is going to give us the x part of our, sorry, I'm trying to think ahead to like, how am I going to write this out? Because I think you might want to see this written out. This is going to give us the x part of our center. I'm not going to write things out. I got pop-ups. Oh, no. Okay. All right. This is going to give us the x part of our center, and this is going to give us the y part of our center, and then this is going to give us our radius. So, yeah, well, let me write on that. Okay, so remember that it's going to end up being the opposite. So, maybe I kind of change my windows here. Oh, that makes that really tiny. Sorry, y'all are kind of being my guinea pigs on this new way of writing here. I'll just write really big, the whole thing. Okay, so the 2 things that we would need to know about the circle to be able to graph the circle are the center and the radius. So the first thing we're going to want to know is the center. The center is at the opposites of those numbers in the parentheses. So with the x is +4, that means that center is going to be at -4 for the x. And then for the y, it says y -2. That's going to be at the opposite of that. So that's going to be at +2. So our center is at -4, +2. The other important thing that we need to know to be able to graph this is a radius. To be able to graph, we need to know the radius. Now remember the equation was equals r squared. So 36 is r squared, which means if we want to know what r is, we have to take a square root, and our radius is 6. Technically with algebra, it's positive or -6, but since we're talking about a length, a radius is a length measurement, we're going to say it's just +6. So now to graph this, what we want to do is grab this dot and drag it to x is -4 and y is +2. And then you can see as I move my mouse around the edge, it gives me a sideways arrow, diagonal arrow, up, down arrow. It doesn't matter where I'm going to grab that, and I want to drag it until I'm 6 boxes away from the center. So right now I'm at 1, 2, 3, 4, 5, 6 boxes away from the center. 1, 2, 3, 4, 5, 6 for my radius, and my center is at -4, +2. And then say, yay! Okay, so that would give me the graph of that circle. Okay, so this actually covered 2 Khan Academies. One of the Khan Academies is just going to ask you what is the center and the radius, and so then you would just type those in. Another one is going to be this one actually on the graphing, so you might actually get this exact question. And then the third one is going to give us some features, and we need to turn that into the equation. So to do this, we're going to think of it as like a fill in the blank with the standard form of that equation. So the standard form of that equation was x minus a, that's going to be one of the blanks, squared, plus y minus b, that's going to be one of the blanks, squared, equals, and then we're going to have a blank, which was r squared. The radius squared is what goes on that side. So I'm just going to put squared, and then we're going to fill in that blank with the r. So what we need to fill in is the a, the b, and the r, which is the center and the radius. So this problem tells us the center and the radius. The center is right here. So the center, we're going to pop both of those into those first two blanks. So in that first blank with the x, I'm going to put negative 6.2. And in the second blank with the y, I'm going to put 5.8. And then in that third blank goes the radius, which is right here, 4/9. And we're going to square that. So to clean this up before we would go to type it into Khan Academy, we want to take care of any minus and negative, and we're going to change that to plus. So we're going to have x plus 6.2 squared. And then we're going to have y minus 5.8 squared, and then equals, when you square a fraction, we square the top and we square the bottom. Squared means times itself. So on the top, 4 times 4, that makes 16. On the bottom, 9 times 9, that makes 81. And so then this is what we would want to type into the blank here. When you start typing, you get your tools. Make sure you open up those parentheses. I'm going to say x plus my 6.2. And then outside the parentheses, I'm going to do the squared, get back down on the level, plus parentheses, y minus 5.8. Outside of the parentheses, I'm going to do the squared, get back down on the level, equals, and then I'm going to have a fraction of 16/81. And check that, and I got it. All right, so you're going to have 3 Khan Academies on this, 1 on the distance formula, and then 3 on circles. What are the features? From the equation, create the graph, and from the features, create the equation. All right, ask me whatever questions you have. I'm here to help. Talk to you later, guys.